Hi everyone, I'm Mr. Lineberger and I'm so glad to be here with you today. There was this old commercial about candy bars. This one candy bar has chocolate mixed with peanut butter. If you didn't know better, you might not think those two would go with each other, but once you've tasted them together, delicious. In the commercial, someone accidentally gets the chocolate and the peanut butter mixed together. They're disappointed at first, but when they taste the resulting mix, they experience sweet bliss. Today's lesson is all about the chocolate and peanut butter of math. Our chocolate is division, and our peanut butter is fractions. Those are two awesome treats by themselves, but when you mix the two, you get sweet bliss. To stick with today's theme, today's lesson is going to be all about cookies. Let's start this party by thinking about fractions. Take a fraction like 1/6. What is a sixth, really? It's a whole divided into 6 parts, like this giant cookie I'm imagining. This cookie is so big, one person can't eat it all. You've got to divide it into 6 and let 5 other people share it. A sixth, then, is really just the whole divided into 6 parts. It's just 1 divided by 6. Did that blow your mind? 1/6 is another way to write 1 divided by 6. In fact, all fractions, if you think about them this way, are just division problems. Think of a crazy fraction like 2/77. That's just dividing something into 77 parts and taking 2 of them, which is the same as 2 divided by 77. We might write this as a formula of sorts. A over B equals A divided by B. If our fraction is 4/7, then we could write our formula as 4/7 equals 4 divided by 7. 2/11 would be 2 divided by 11. Are fractions just division? Yes, they are. Well, what about those fractions greater than 1? Yep, those are still just division problems. Take a fraction greater than 1 like 18/5. You can represent it as 18 wholes divided 5 ways, which is the same as 18 divided by 5. Or think about our formula. A over B equals A divided by B. 18/5 equals 18 divided by 5. No matter what, you can think of fractions as top number divided by bottom number, or numerator divided by the denominator. Time to get some cookies involved. Imagine I have 3 friends. So there's 3 friends plus me, that's 4 of us. We're splitting a box of cookies. If there are 20 cookies in a box, how many cookies do we each get? We could represent this as a division problem. 20 divided by 4 equals some unknown quantity of cookies. We could set this up as a partial quotient problem, like this, with 20 inside the box and 4 on the outside of the box. We could draw 20 cookies, then count them off for each person. Hey, we could even just open a box of cookies and count them out, which sounds like the tastiest plan I've heard so far. Or we could represent this as a fraction. 20 divided by 4 is the same thing as 20/4. If we simplify that fraction, we get the answer, which in this case is 5. How did I simplify that in my head? I just asked myself, What times 4 equals 20? 5. 5 times 4 equals 20. So let's make this just a little trickier. Imagine, instead of splitting one box of cookies with my friends, what if I split 7 boxes of cookies? How many boxes of cookies will we each get? If I think of this as a division problem, I want to divide 7 boxes by 4 people. 7 divided by 4 is the same as a fraction with a numerator of 7 and a denominator of 4. If I want to, I could stop there. Each of us gets 7/4 boxes of cookies. That's not very easy for me to picture in my mind, so I want to turn this into a mixed number. 7/4 is the same thing as 4/4 plus 3/4. So 7/4 is 1 3/4. That's easier for my brain. If we split the 7 boxes of cookies, each of us gets 1 whole box plus 3/4 of a box. Staying in this same line of thinking, what if we change our problem a little? Instead of 7 boxes of cookies divided by 4 people, what if we did 4 boxes of cookies divided among 7 people? How would we write that? If you said 4 divided by 7 or 4/7, you're right. And there's your answer. Each person would get 4/7 of a box of cookies. Let's picture what that would actually look like. Here's my box of cookies, like so. I'll divide it into 7ths. So that's 1, 2, 3, 4, 5, 6, 7 equal parts. Now, let's color in 4 of those. 4/7. As you can see, if I divide my box of cookies in half, 4/7 is just a little more than half, so we're talking about a little more than half a box of cookies for each person. Let's wrap things up with one more problem. Imagine that I'm going to give these cookies to my class. I have 20 students in my class, and I have 32 cookies to give them. I have 4 jugs of juice to go with the cookies. So I put my class into 4 groups. First, how many students are in each group? Then we want to know how many cookies will each group get. Finally, how many cookies will each student get? There's a lot of parts to this problem, so let's break it down step by step. First, let's set up the groups. We divide 20 by 4 to get 20 students in 4 groups. Let's represent that as a fraction, 20/4. If we're satisfied with that, there's my answer. Each group has 20/4 students. I need an easier number to work with, but I know 20/4 is the same as 5. Each group has 5 students. Now I'll figure out how many cookies per group. I take 32 cookies and divide by 4 groups. That's 32/4. Each group gets 32/4 cookies. 4 times 8 is 32, so 32/4 equals 8. Each group gets 8 cookies. 4 groups, 8 cookies per group. The last part is knowing how many cookies per student. 8 cookies per group divided by 5 students per group. Each student then gets 8/5 cookies. That's the same as 1 3/5. So each student gets 1 whole cookie and 3/5 of another cookie. We can check our math by drawing a model. Here are my 8 cookies for the group. I can give a whole cookie to each group member like so. I'll divide the remaining cookies into 5 parts each. Now, When I want to give those out, each group member gets 1/5 of the first cookie, 1/5 of the second cookie, and 1/5 of the third cookie. That's a total of 1 whole cookie plus 1, 2, 3 fifths. 1 3/5. Sometimes drawing a picture really helps me understand the problem. Today we learned that division problems can be represented as fractions. The numerator is divided by the denominator. If you think of division problems as fractions, then often the answer is right there. My favorite fraction is that fraction of a cookie.